All right, section 2.7, our last section in chapter 2, or chapter 2 and 3. We kind of combine 2 and 3 together, but this is section 7, I guess, of all of that. We have to talk about phase changes. Now, in the last section, we talked about phase changes and the energy required in a phase change. Let's just real quick, let's go over the energy and the differences between the 6 phase changes. We have melting and freezing. Melting. All right. What happens when something melts? Well, we have changes in energy. Melting is going from what? Let's make sure we get this right. We're going from a solid to a liquid. And freezing, we're going from a liquid to a solid. Now, here's the goofy thing that we're going to talk about in class. Freezing is a warming process. And you're like, what? How can freezing be a warming process? Well, think about it. Freezing is a warming process. When something freezes, right, energy is released to the environment. Right? It has to give off heat. That heat has to go somewhere, and it gives it off. Here's a prime example, and you can Google this if you want. Why in Florida? All right, so Florida, what's Florida known for growing? What fruit does Florida grow a lot of? Oranges, right? Oranges are a citric fruit. Oranges can't grow in cold weather. Every once in a while, they will have a frost in Florida like we had this morning. So they will have a frost. To prevent the oranges from getting frosted and damaged, because if a fruit freezes, it's ruined. What they'll do is they'll turn on the sprinklers in the orange grove. And you're like, well, why would they turn on the sprinklers? Well, if it gets cold enough, what's going to happen is the sprinklers will come on and the water will coat the fruit. Then what will happen to the water is it will freeze. The water will freeze. But since water is a warming process, when the water freezes, it has to give off that heat somewhere. Where does it give it heat off to? It gives the heat off to the orange, and it insulates the orange. So freezing is a warming process. Melting is a cooling process. So it's kind of backwards from what you've kind of learned, but think about where the heat goes. If I'm freezing something, the heat has to exit the system. So it's giving off heat when something is being frozen. If we go up to our next phase changes, we have vaporization, condensation. And vaporization is more evaporation. So evaporation is a liquid, and sorry for my goofy L's, a liquid going to a gas, and condensation is a gas going to a liquid. Now on the previous slide, you were able to give me a bunch of examples of melting and freezing. You guys see melting and freezing all the time, right? Snow melts. Ice cubes melt, rain freezes, it's freezing rain. I put ice cubes in the freezer, it freezes. All right, good call there. That's this. Evaporation and condensation. Evaporation, a liquid to a gas. What's an example of evaporation? It rains. There's a puddle on the ground. I walk to school in the morning. The puddle is there. When I walk home, the puddle is gone. That puddle has disappeared. That's evaporation. Or vaporization. If I boil a pot of water, my water goes from a liquid to a gas. How about gas to a liquid? Gas to a liquid. Fog is condensation. So condensation is gas to a liquid. Fog's an example. I have these water molecules in the air. When it cools down at night, the water comes out of its gas state and slightly into its liquid state in the air. So fog is a great example of condensation. If it happens to be on a really cold night, like is happening in the fall now, when my fog freezes and I go from a gas to a solid, that is frost. Right, that is frost. There's little ice particles on things. That is frost, and we'll talk about that in a second. So evaporation, liquid to a gas. Now the heat that it takes, the amount of heat that it takes to do this is called the heat of vaporization. Don't worry about that. Right. Evaporation takes place at the surface of a liquid, though. So evaporation only takes place at the surface of the liquid and occurs at a temperature less than the boiling point. I want you to know that evaporation takes place, all right, at the surface of a liquid. All right, and we're not going to study too much about vapors or vaporization, but vaporization is when a substance goes from a liquid to a gas below the boiling point. What's a common substance that has a vapor? Right. Some of you guys might like the smell of this vapor. You guys ever pump gas, or your parents have pumped gas and you're sitting in the car and you smell gasoline? That is a vapor. Right, so that is a vapor. The gasoline's not boiling, because if it was boiling, we'd have big issues, because it would probably start on fire. It'd be flammable almost if it was boiling. But it vaporizes, and a vaporization is just the gas-like state of a liquid or solid at room temperature. And boiling, we're not going to get into the official definition of boiling. Well, we're going to save boiling for when we come back and talk about pressure and physical science a little bit. But boiling has to do more with pressure than it does with temperature. All right, last couple things here. We talked about melting, freezing. We talked about evaporation, vaporization. Condensation is when we go from a gas to a liquid. A great example is fog. We talked about that. All right. Last one I want to talk about is sublimation and deposition. These are the two that you have really probably not a whole lot of knowledge with. What is sublimation? Sublimation is when we go from a solid directly to a gas with no liquid in between. And deposition is where we go from a gas to a solid. Deposition is not common, but sublimation can be. Anyone can think of a substance that goes directly from a solid to a gas. You guys may have seen this before. Right. Dry ice. Right. Dry ice. Dry ice goes directly from a solid to a gas. There's no liquid form of dry ice. So kind of keep that in mind. If you've ever seen dry ice, I'll show a couple videos tomorrow in class of dry ice. But sublimation is when we go solid to a gas. So we have 6 types of phase changes. We have melting and freezing. Melting is liquid to a solid. We have freezing, which is, melting is solid to a liquid. Freezing is liquid to a solid. We have condensation and evaporation. Evaporation is a liquid to a gas. Condensation is a gas to a liquid. And then we have sublimation, which is a solid to a gas, and deposition, which is gas to a solid.